Hello, my name is Asteriadis. I am an associate professor at the University of Maastricht in the Netherlands, and today I'm going to present a paper that we published about 1 year ago at the Asian Transactions on Interactive Intelligent Systems, and we have had the happiness to be invited also in IUI 2021 by the organizers in order to present it here. Actually, this is work of my PhD candidate Dario Dotti, and the title of the work is Being the Center of Attention, a Person-Context CNN Framework for Personality Recognition. So, I'm not going to start with any groundbreaking information for you, and I'm just going to say that our personality is manifested in a number of ways, among which is also our non-verbal behavior, so behavior that is coming from our facial expressions, body movements, etc. However, it is a fact that although personality computing is an area that has received a lot of attention in the last years, when it comes to making use of computer vision and artificial intelligence techniques for inferring a user's personality, most works are coming from the branch of facial analysis, so facial expressivity, etc. This means that we only have a small body of works that deal with bodily expressivity and how this relates to our personality traits manifestation. So in this work, our goal is to propose a system that looks into body dynamics in two different contexts in order to examine whether we can generalize as much as possible. So we're going to look into two different sorts of data. One piece of data is coming from a social event, and our other direction in terms of data analysis is coming from a non-social context. So a person being alone in one room interacting with objects, and yeah, so no social interactions. Right. So to give a broad overview, we are splitting our data representation in three different branches. And in the end, we are fusing all this together, making use of a deep neural network, a CNN in particular. So the three different branches are the following. The context proxemics descriptor, which is a descriptor that is describing how the target person, so the person whose personality we want to predict, relates to other individuals or even other objects in the environment. The person descriptor, here in the middle, that has to do with how the individual motion characteristics of a person, so no relations with other people or the environment, can tell something about their personality. And finally, we focus in social groups, so groups of people that stand close to each other and talk to each other. So 2-3 people, not considering the rest of the people in the room, for example, in order to see how motion dynamics work within this group, and how an individual can impact the rest of the group, and then can we say something about this individual's personality. Right, let's start from person motion features then, so features that have to do only with one's own bodily expressivity. We have used the OpenPose library to extract a number of joint coordinates on the body, and then we are looking into comparing those joints with 4 fixed reference points, as we say. In our case, we use the shoulders and the hips, and the relation of each of the remaining joints with regards to the reference points is then transformed into cylindrical coordinates, and we of course extract these features across time as well, and we end up with these 3 2D map representations, each one standing for the radius, the theta, and the z value of the cylindrical coordinates. So these 3 2D maps encapsulate information that has to do with how each joint relates to 4 reference joints on the body. Next, we are extracting features that have to do with the subgroups, the groups of people that talk to each other, for example, in a cocktail party, as we will see later on. And what is happening here is that we have used the clustering and unsupervised approach in order to split the people in the scene into a number of clusters, which correspond to groups of people talking to each other. And then excluding the target person, we see how the motion features of the rest of the people work. So we take the motion features are, as we saw in the previous slide, of each individual in the social subgroup, and we apply a pooling strategy, max pooling or average pooling, in order to acquire a compact descriptor for the whole group except for the person in question. So we want to see how the group behaves in relation to who our target person is. Right. Thirdly, we are looking into how our target person's physical coordinates relate to those of other individuals in the scene. So, for example, if we are talking about a shy person, we would expect that this person would not be close to people all the time. If we are talking about a highly agreeable person, then we would expect that this person would be close to people, close to other individuals. And for this reason, we want to see what are the relationships of this person with regards to other people in the group. And for this reason, we are again using cylindrical coordinates, but not on a bodily basis, but by comparing the coordinates of individuals with each other using a reference, just one reference point on the body of each individual separately. And of course, it doesn't make sense to use the Z coordinate here because we don't really care about how tall or short a person is, but we only care about how far they are from each other, right? Similarly to this, but looking a little bit more tricky, we are making use of the usage of the space by an individual when it comes to non-social settings. So, as I said before, these are settings where there is an individual alone in a room and they interact with the environment. In order to see what are the important areas of the environment with which this individual interacts, we apply an unsupervised method by looking into hand motion features. Unfortunately, I don't have time to explain this now, but you can look for more details in the paper. So we're looking at how the motion of the hands differs across different areas of the scene. And we apply an unsupervised clustering approach here, making use of Gaussian mixture models in order to tell what are the regions of interest in the scene. And we then apply exactly the same thing like we applied in the previous slide, but in terms of other people in the scene, you have objects in the scene. Now, how does this all come together? For bringing all this together, we have made use of the pre-trained VGG19 model. But here we stopped at the VGG5 layer, and then we trained our own two-layer fully connected network, followed by a softmax classifier in order to that points directly to the most possible personality trait. So depending on the problem, we've used these three descriptors coming from the three CNNs, and taking as input the descriptors, the cylindrical coordinates as we described them before. So we have the representations that we discussed before, passing through CNN networks and then fused all together in the end through concatenating them and passing them through two layers, a two-layer fully connected network and softmax. Finally, for our experiments, we used two datasets. The first one was the salsa dataset, which consists of a social context where you have individuals interacting with each other in a poster session, like we would have if we were able to meet for this conference, and also the cocktail party, so the coffee break of this conference was used. Data from the coffee break of this conference were used for analyzing the dynamics in the nonverbal behaviors of the individuals. Secondly, we are using a dataset that we recorded a few years ago, where we asked 45 individuals to interact with their environment. We left them alone in the room, and then we asked them to do a number of tasks like make some tea, look for some objects, etc. And then by analyzing their bodily behavior, we want to tell something about their personalities. Unfortunately, my time is finishing soon, so I will simply mention here that we made use of two personality trait models. The big five personality traits, which is probably the most common model used in personality computing, and then the three personality traits that are actually a combination of the big five traits here. So the big five have to do with neuroticism, openness, conscientiousness, extroversion, and agreeableness, whereas the personality types model consists of the under-controlled, resilient, and over-controlled traits. Here are some results. We conducted an ablation study by mixing and matching different descriptors from the three ones that we discussed earlier. And we also compared with previous approaches, which have been applied in similar problems, but it was the first time here that we applied them on these specific datasets. And it is worthy to say here that we followed leave one subject out protocol, meaning that the test subject had nothing to do with the rest of the training data. So every time we were using a subject that the system hadn't seen during training. Some more results on the non-social dataset here, and here are results on the Big Five model, which I would like to very briefly comment on. So as we see here, for the salsa poster session, so for the social dataset, we see that the openness to experience trait has the highest accuracy, which means that this part of this dataset is very well fitted for this kind of feature, because we are talking about academics here, we are talking about researchers here, so openness to experience is probably something that shows really easily in a poster session. Whereas extroversion and neuroticism showed mostly in the cocktail party, as they call this part of the dataset. On the contrary, extroversion was also apparent in the non-social dataset, which means that we don't show how extrovert we are probably when we are dealing with stuff in a room by ourselves. So this seems to be also in accordance with psychology. And this concludes my presentation and my video. If you want to have more details about our work and our works in general, I would encourage you to visit our website and get to know more about us. Thank you very much.